Anyone have problems launching the sentiment analysis lab? If not, let's get started. And by started, I mean I just click on here. Same thing. If this thing is still blacked out, remember the wise words: sign in, clone, and run. So after that, you can just click on this and it should run. I will come back and check at 21:22. For the purposes of this, right, if you guys are running on whatever platform, right, make sure that your kernel is on Python 3.6. Yeah, just make sure that it's Python 3.6. Well, we have F#. Anyone have problem coming to this page? Okay. Then I'll start with a bit of theory so that you guys have a bit of time. Okay. So in sentiment analysis, right, we generally look at two kinds of sentiment analysis. So firstly is what we call the supervised sentiment polarity classification. Very cheap. Later I break it down for you. Second is what we call lexicon-based sentiment polarity classification. Sounds even more cheap, but it's actually more simple. Let's start with supervised sentiment polarity classification. What is that? When broken down, right, it basically means we're just supervising the classification process of sentiment polarity. Sentiment polarity is basically, you can imagine it, polarity is like, you know, how positive or how negative it is. So you're just supervising the classification of a process of how positive or negative it is. That's all. But when we say we are supervising it, it assumes that we have training data, we have testing data, we have evaluating data. But in this case, we won't touch evaluation data. It's just training and test. So in this case, because we are supervising the process, we provide the training and testing data, and then we use an algorithm. It can be designed by us, it can be just an algorithm that you rip off somewhere or you learn somewhere to classify the sentiment polarity. The more accurate the sentiment polarity predicted, then the better the algorithm, because it predicts it better, more accurate. So in this case, we will look at two very basic algorithms called naive Bayes and maximum entropy. So the first thing is the same thing. Shift enter to download all your libraries. Okay, so same thing. Once it's done, it will output true. So if everything's okay, I will move on to the next one. So remember our steps for data preprocessing. We mentioned tokenization, we mentioned stop words and rejects removal. So generally we did tokenization, right? But we did not remove any form of stop words. That is because in just now's case name entity, we need the words. We need to know the grammatical structure. We need to know the where the determinants are and some where the prepositions are. Therefore, we don't really remove them. So stop word and regex remover is basically on a need to basis. In this case, because we are using sentiment analysis, words like the, in, are, all this doesn't add value to the sentiment analysis component. Therefore, we use stop words we use the stop word removal technique. So in this case, we can see our stop list, we just import the stop list. So someone very kindly just provided us a list of all the stop words if there are or whatever, and we don't need to compile it ourselves. So we just import it to the first sentence. The stemmer is, we are basically going to use the Porter stemmer. And same thing, we don't need to write the entire algorithm method out, we just import it. So now we have the stop list and the stemmer. Let's look at the training file that we're using. Remember, in this case, we are using Supervise. So in this case, we are going to provide our own training data. So let's look at the training file. Where's my training file? Sentiment analysis. UIC review data. Nikon, right?
Canon.
So this must be my test data. Yeah. So in this case, what you're looking here, right, is basically plus for positive sentiments, minus for negative sentiments. So let's have a look. Randomly select, I'm easily enlarging pixels to 8 blah 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 blah, with no loss in picture quality and best settlement. All these are very positive words. And a human has labeled this sentence to be positive. Another example, this is my first digital camera and what a toy it is. And this is what a human has classified. Just to emphasize, this is what a human has done, not a machine has done. Because a machine has to do sentiment analysis to be able to determine whether it's positive or negative. So why would we use that to train our data, right? So generally, when we look at training data for sentiment analysis, we always look at what we call the golden source of truth. And the golden source of truth, more often than not, right, is humans. So human annotated data, because what we are trying to do is get the machines to emulate our ability to recognize sentiments in a sentence. So more often than not, training data will be human annotated. There are other creative ways. For example, in Twitter, if let's say you go to Twitter data, you get the tweets and stuff, right? If a person writes hashtags happy, for example, then you can, it's like essentially the guy who wrote the tweet annotate themselves up. So you can just retrieve it and use it. But in this case, this is really just a lot of manual work. So why I'm showing you this is for you to get an idea of how the training data is like. Minus in this case is lens visible. So this person determined that this is negative. Must be a camera fanatic because I don't know why. Quite bulky. Okay, this makes sense. Like, you know, it is quite bulky, so it's a negative thing. Not very ergonomical. Yeah, it's a negative thing. Yeah. So you can see how the person has classified this as positive or negative. Let's look at this. So now we have the training file, and you can see how the human has annotated it. We open the training file. We have the labels and the corpus initialized as empty arrays and instantiated as empty arrays. So what we're doing here is now we are essentially doing our pre-processing. In this case, for every line that we notice, so for a line in F being the training file, I should have called it file, but yeah. So let's say, did I close it? Yeah. For a line in F, we're looking at each line. For this line, for this line, for this line. We strip. So when we say we strip the line, what we're actually doing? Line dot strip. I think we're removing blank space. For each line of the input file, extract the label and the text. Ah, I think I recall already. Yeah. So in this case, what we are doing here, right, is you notice that I put there's a positive or negative at the front, right? So in this case, what essentially that method is doing, right, is trying to get the label and the sentence. So in this case, what I'm trying to say is this sentence is associated with positive. This sentence is associated as negative. That's what the code was doing at that stage. After that, labels, so labels is an array. Anyone don't know what's an array? Everyone knows, right? So we will put this label into the array. So you can see, like, okay, in this case, and of course, we will have the text, but I'll come to that later. So in this case, the array will have plus, negative, negative, like that. So you just record that in the array. Then, now we are going to tokenize the text. So what we do is we take sentence equal to word tokenize text. We're just tokenizing the entire text over here. Automated process. All these are basically other pre-processing steps that we may or may not want to touch. So for example, do we want to standardize text in lowercase? Sometimes we don't need to. In this case, we notice that everything here is lowercase already. Do we need to standardize it to lowercase? We don't need. Stop word remover. Just now, example, in NER, we didn't do stop word remover, right? In this case, do we want to do stop word remover? We don't know. Optional. We'll find out later. Stemming. Do we want to stem everything? Does it make sense for us to stem? We can try also, we find out. Basically, all these are pre-processing steps. After we have done all this, we append it to a corpus. A corpus, you can think of it as a bucket of text. So after that, we close the reader. Then after that, what we do is we will create a dictionary, a corpus. And what basically all these does, right? Let's see, how do I explain this? I'm not gonna explain, it's too tough. So anyway, after what this does, right, is basically it's going to go through the labeled data set over here. So remember what we are doing here, right, is we are preparing the train data, correct? So we have the text, but that's not enough. We have to prepare it in a way that the computer will be able to conduct the supervised learning effectively. So in this case, we're only preparing the data to train. What this does is basically we're going to create labeled data sets, positive, and the associated words that are positive. So therefore, what we have is, you can think of it as, we have a positive, and then we have this entire sentence which is tokenized. Or, if we do stop word removal, it will be class, purchase, recently purchased Canon PowerShot G3, extremely satisfied purchase. Yeah, then that will be your training data, and the label will be positive. So that's essentially what we do. If you are wondering what Dr. Bo is, it's basically a bag of words. What's a bag of words? It's just a bag of words with no order. You just imagine you take a bag and you stuff all the words inside.
So when you stem it,
yeah,
you have positive, and then and then you have the negatives also. Most of the negatives were based on the fact that it had a negative
word associated.
But when you stem it, you remove that word, right?
No.
If you stem it, the not will be removed, isn't it? Because it's just a conjunction.
That's a very good thing. So it really depends on whether the word not is defined in the stop list. Yes. So in this case, right, in the case of sentiment analysis, right, most of the time I think stop lists don't include nots and stuff, because obviously they are negators, which it doesn't make sense if we remove the negator and from happy to not happy, completely different meanings. So I think in this case, not will not be included. Not will not be included in the stop list. Yeah.
How about happy and unhappy?
Oh, so in this case, right, so if let's say unhappy, right, when they actually stem it, right, it probably is unhappy. It probably won't be seen as happy. So usually when we think of when we stem words, right, usually we take the later part of the word out, not the prefix. Yeah, the one is about suffix, is it?
Yeah, suffix.
Suffix, right? Yeah. So once you're done with all this, right, what we're going to do is we're going to train a classifier. So remember, all the steps above, right? Sorry, I keep looking there, I never look here. All the steps above here, right, is just to prepare the thing for training. After this, we only finish preparing the training data. Next thing is to actually use a classifier. And thank God, we don't need to create the classifier ourselves. We can just use the knife-based classifier to train the data. So everything we have done up to here, right, is just so that we can put this label training data in the right format for this method to accept. So that is essentially data pre-processing. So once you're done with this, you can click on Shift Enter, and then you wait a while. It will print out the messages once it's done. So you'll finish reading the sentence, preparing the data, and training the classifier. So now you have trained a classifier. How good is the classifier? Right? That's the question, right? But before I answer that question, let's give some people some time to run this first.
Can we edit the negative words and positive words as and when required? Is it recommended? So if you go back to your list of files.
This one is it?
And the list of files, yeah, on the sentiment analysis page. the initial page.
Oh, okay. This one.
Yeah. So there's positive words and negative words dot text, right?
Very good.
So let's assume that okay, I don't have a word called unhappy as she mentioned.
Correct.
So can I edit it and then put the word unhappy, and then will it start recognizing it when I rerun that?
Okay, so a clarification, right? In this method that we have shown you just now, right, we are supervising the process of identifying negative and positive words. From what I have shown until now, right, we have actually not used these two files yet. These two files are for a later part of the lab.
Okay. So from where does this identify? Okay, these are positive words, these are negative words.
Correct. So in this case, right, what we are doing here is we're assuming that we have a lot of training data to train our own classifier, correct?
Yeah.
But that is not always the case. In production environments, in any kind of company, banks, supply chain, or whatsoever, right, most often we don't actually collect our own data and prepare the data just for minimal, sometimes it doesn't make cost sense at all. We invest so much time and effort to create a classifier which has subpar performance. So what people have done is people already classified the negative and positive words. Remember, what we're doing here is we're supervising the classification process to determine what is positive and negative. But if other people have already classified them, we have the option of using the fruits of other people's work. And this is where these two come in. So just now I mentioned there were two things. Supervised sentiment polarity classification, that's what we're doing now. Lexicon-based sentiment polarity classification, which sounds more cheap, is the one that rips off other people's fruits and just uses them. But I will explain that even more in depth later, which is in the code. So I'm going to assume that everyone is able to train the model. So let's see the testing of the model. Notice the first thing is that the test file is completely different. It's a completely different file, right? This is Nikon, the other one was Canon. Yeah. So this also basically is accentuating what Ha mentioned just now, that we don't want bias in when we're testing our data. So we have to usually test it on a completely different data set. So in this case, what we are doing here, right, is the same thing. We're going to split it into positive, negative, positive, negative, right? But in the test data set, there is something fundamentally different from the training data set. In the training data set, right, where what the machine does, right, is that it looks at the text, it says, okay, this should be positive. And then we look at the answer and say, oh no, this is actually negative. Then you readjust the weights of the features to make it predict negative. Then it goes on to the next one and says, okay, this one should be negative. Then it looks at the actual result, oh, this is negative, good, move on next one. This is negative, hey, why is this one positive? Then the machine will readjust the weights again. In the testing data set, no more readjustment is done. What is all that's done, right, is it's going to predict and it's going to match the score and see whether it's correct or wrong. And then we get a score from there. So that's the difference between training and testing data set, essentially. So let's look at the testing data set, and we have covered all the way to here. You notice that the code is largely the same. To be fair, if we don't apply all of this in the training data set, we shouldn't apply all this in the testing data set. It wouldn't make sense, right? So after we have done this, what this does, right, is basically it's going to test the accuracy of the data set. So when we test the accuracy, it's essentially what I've told you. It looks at the sentence, it makes a prediction, and it ticks if it's correct, crosses if it's wrong, and it collects it collects the results. In reality, it's not as simple as tick and cross. There's things in classification algorithms, we have things like precision and recall, which is a bit more advanced for us to learn. We have things like entropy, for example, which we will not get into because of lack of time and because it's a basic class. It's not supposed to cover all this yet. So if we were to run this, we are going to use a very basic thing, just get the accuracy. You notice that accuracy is 0.64. So is that a good score? Not really, because the score is against 1. Let's see what we can do. And when I say let's see what we can do, I mean it's your turn.
0.88125.
Sorry?
The accuracy.
0. What?
88.
You solved it already?
Yeah.
Wow.
Just run it.
Okay, so let's see if anyone can get better score than him. Just joking. Yeah. Wait, just run it. Oh my god, I provided the answers. Okay, sorry. So that I provided answers. Wait, I remember oh, okay, sorry. I put this part wrongly. Okay, so let me go through this part, okay? So the above use naive Bayes to train the classifier, right? So naive Bayes is a probabilistic or conditional probabilistic statistical algorithm that tries to make a prediction based on certain premises. Max N is basically a different kind of model. It tries to make predictions completely differently based on maximum entropy. How it's done, not covered today, as mentioned. Also because I didn't revise. But yeah. If you were to see, most of the data is the same except that I changed this from naive Bayes to max N classifier. The beauty of coding. So everything is essentially the same except that I changed it to max N classifier and I changed it to a different data set. And as mentioned, if you were to run this, oh god, you have to actually train this. Okay, so what happens is it will, when you are training this, right, you're going to train for 100 iterations. So after, you notice that as it goes by, right, you will see that the accuracy is increasing.
Keeps training.
Yeah, but remember we are training it on training data. So obviously it's not gonna it's not an indicator of performance because we are testing using training data. It doesn't make sense, honestly. So this is just a way to, what is more important is the log likelihood over here. So what is log likelihood? So when we talk about log likelihood, we're actually talking about this thing called the maximum likelihood estimator. In essence, it's trying to see the likelihood that the process this model goes through will actually produce the data that we are testing, that we have. So what this means is that how to say well, basically we're trying to maximize the likelihood that the data is correct lah. The maximum likelihood for layman terms. So why is it log over here? Is because when we take it a log scale, right, it's actually what we call, you guys know what's monotonically. Okay, basically a log graph is increasing, right? So yeah, that's the sense. It is going to increase, and we take the log so that we actually have a scale of it. So you will see that it is actually increasing from because negative 0.6 is a bigger, smaller, more negative number as opposed to negative 0.019, which is more positive and thus a more positive number. After you finish the training, the classifier will see that the accuracy is 0.86875. That's all?
Yeah.
Okay. But yeah. So we can see that using a different classifier, we actually have a much better enhanced improvement. Well, I use a lot of good words. It's a better model. It's a better accuracy. So now, my challenge to you is that just now, we have done all this, right, but we did not do the stop word removal and the stemming, correct? So now, why don't we all try? Copy the code, do the stop word remover, do the lemmatization, the stemming, and then see whether it actually beats the score of 0.6875. So it should be fairly straightforward. I will come back at 2150 to go through the last part. Because at 2200, there's no more icon. So you guys don't want to be stuck here, right? So 21.
So just copy the code.
Yeah, just copy the code and uncomment and see how it goes. At the same time, you can take a step back and look at the code and try to understand what's going on as well. In fact, right, you guys can even try testing it on a different data set. So just now we mentioned, what we saw is that we tested it on the Nikon data set, right? We can try, in the UIC review data, you have a lot of other data sets, so you can try it on others. Just remember that you should not train and test on the same data.
What all did you call? Just the word or? No, we're just trying to do the optimal uncomment and that's it.
Yeah, uncomment stuff. Yeah. I had to make it. running on your own computer. Can you open your
You just need to make sure that the input is correct. Sentence will be text. Be okay. How do I know if it use the software or is there like an output, like a debug where I can see like a console, right, where it says if it like passed through which just below the maybe the this one I don't know whether it is used.
Okay, has everyone done it? It should be fairly easy, right? It's just uncommenting. So,
Reduce.
yeah. So if I'm not wrong, the score should reduce, right? The score reduces after.
125.
Yeah. So the score will actually reduce when you remove the stop words. So what does it mean? Does it necessarily mean it's bad? Maybe not actually. So it really depends on how you want to view the data. So in this case, if you are using the same data set and the accuracy decreases, then you will probably think that the stop words are essential when trying to identify whether a particular sentence. It simply means that stop words are more useful when trying to identify, trying to classify sentiment polarity for this algorithm. But for other algorithms, it may not be so. So always remember, you can always play around with your pre-processing for every model. So for the very last part, because I don't want to hold you all guys up, lexicon-based sentiment polarity classification. As mentioned just now, when someone pointed out the negative and positive text files, we don't have the luxury of training data all the time. So in cases where we don't have the training data, and we still want to use sentiment analysis, we can always use lexicon-based. Lexicon-based basically means someone has already annotated for us the negative and positive words. So let's have a look.
That accuracy is 0.8812.
So, sorry?
Accuracy is higher
When you
use a lexicon.
use a lexicon, yeah, correct, yeah. So in this case, right, when you use a lexicon, right, what you see is over here, right, you notice that they don't have any pluses or anything. In this case, it doesn't even have a score attached. But if you use other lexicon, like for example Vader, or you use Afin, right, they actually have scores. But that's not the point. The point is that in this file, everything here is deemed to be positive. So very naive models of sentiment of lexicon-based sentiment models, right, will simply add +1 if a word from here is seen, -1 if a word from the negative word is seen. That's a naive model. But then there are certain edge cases which may not necessarily make sense. For example, what happens if, let's say, in the case of sarcasm, for example, how do we catch those?
So if you say, I mean, if you negate a word, abundance will be present, but then somebody says it was not abundant. So you're negating it. Will it be caught in the lexicon as a negative, or will it like concatenate both of those to be counted as one, or will it still count those two as separate words?
So for as I mentioned, naive models, right? What I have seen so far is that not, when they see not, right, they multiply -1.
Okay.
Yeah. So in that way, right, you preserve the magnitude of how positive or whatever it is, You minus 1, it will just flip over and become the magnitude of negative.
See, so for example, I can make a statement saying I was unhappy, and unhappy will be in the negative word.
Yeah.
I can also say the same thing, I was not happy.
Correct.
So the not gets a -1, but the happy gets a +1. So it's, it's like...
No. So the not will multiply a -1. So for example, let's say, happy is a score of 0.5. Not happy will give it a -0.5 because you're multiplying it by -1.
Okay.
And for example, unhappy, right? It is possible that unhappy is given a score of -0.4.
Okay.
So these are the drawbacks of using lexicon-based sentiment analysis. Sometimes naive models don't perform that well.
Okay.
So in this case, what happens is when you use all this, right, what you're doing here is you have a positive lexicon and a negative lexicon. And then after that, what you're doing here is essentially that you're checking if, so this is the naive model that I was mentioning. If the word, W stands for word, if the word is in your positive dictionary, you score +1.
Yeah.
If your word is in a negative dictionary, you -1. Then after your predictor labels, you will put off plus and stuff. So why do you have a predictor label over here? It's just for them to do, just for the machine to be able to do their tabulation of accuracy scores. So in this case, what you see is for every correct one, so what they do is the predictor labels versus the actual labels. For everyone, you +1 correct, then you take it over the entire data that you're testing against, and then you get an accuracy score. So as measured, if you want to see, it actually outperforms the previous model, but it is not always the case. So to sum up, it really depends on the use case that you're looking at and the kind of situation that you're in. For example, if you're in a bank and for some reason your bank have been accumulating lots of data for sentiments, like loads of sentiment scores of customer, they always ask you to do customer feedback, right? And maybe they get their HR or someone to go and annotate this. You have a huge amount of data, right, to train your model on. Why is this necessary? Because certain stuff, like for example, let's say we use your lexicon base, right? You have words that here that may not be present in a financial situation. So for example, maybe bull. Bull is generally seen as good lah. Actually, I don't know whether bull is here. Bullish is here, for example, yeah. But my point being that, yeah, and bear, I don't think bear is negative. It would be quite funny if it is. So my point being that certain financial terms and stuff have positive or negative connotation in it that may not be present in the lexicon that you're using. Therefore, if in your company you have the data to train it, it may be better to train it because it's more customized to your end goal. But if you don't have the training data and you still want to leverage this, you can always use a lexicon-based model. So yeah, I didn't have time to go through. Actually, I can. Last one, topic modeling. So don't read. So what you see over here, right, is basically me trying to initialize the stuff. So let me show you. Let's see, news. So over here, right, what I have is basically, I mentioned 100,000 news articles just now, right? Now, I tried the 100,000 news articles and it took half an hour to process everything. So in this case, I only have 7,000 over here. What you see is various kind of news. For example, Mongolia is facing political gridlock on Saturday with ruling party, blah, blah, blah. You can immediately see how this may be useful for financial sentiment analysis use cases, right? Because in this case, this may affect your FX pricing with that company, of that country. This may affect, and if this country has trading relations with other countries, it may also affect your pricing of your bonds with that country, for example. So this is useful, you can see. Question is, how do I know inside all of these texts, so many texts over here, right? How do I know what is what kind of topics there are in the text? Because not all are going to be relevant, right? So having already run the topic modeling, what I have here is essentially I've indicated that I want to see 40 topics. So in this case, what we usually do is we vary the number of topics. Then after that, we get a coherence score. We draw a graph and we see when the coherence score start to plateau or drop and stuff. And we use that kink as our best point. So it's very theoretical, but basically, let's have a look at the topics here. So in this case, I did not annotate anything. I did not need to read 7,000 plus articles. This is what the computer generated. In topic 1, we say US says Mr. Million time Chelsea film, whatever. We don't know what this topic really is. But for other topics, you can see that it is quite clear. In this case,
these are your top 40 occurrences of the same.
no, the top. So the top is not top 40 occurrences, but rather top. Not even top. It basically 40 topics, 40 clusters of word relations that occur in the same subset based on how often they occur together. Yeah. So in this case, right, certain stuff like million and US will likely occur together a lot. Maybe because it's a capitalist country. Chelsea and million, maybe because Roman Abramovich is very rich. And film years, for example. Basically, sometimes these topics don't make sense. Maybe I specified too many topics, for example. Maybe it needs lesser topics to be more accurate. So, but what you can see is that other topics are better identified. For example, plane drop, African trial, Friday, South Africa, airport flight crash. Probably talking about topics where there's a airplane crash, or there's drops, negative sentiments in general related to Africa, for example. So we can label that instinctively by looking at the keywords that's associated there.
But these keywords that you've picked up in every topic are also predefined. These are all 10, right?
10? Oh, so I predefined that I want to see the top 10 keywords of these clusters. So these clusters may have hundreds of words all correlated with each other, right? But I don't want to see all of that. I just want to see maybe 10 to get a sensing. So if I were to actually block all this out, right, and I just show topics, right, print topics. Oh no, because I didn't run it. Damn it. Do I have time to run it? Probably not. Okay, so basically I don't have time to run it, but yeah. It will take a while, and I don't think we have the time. So anyway, if it loads, it loads. If it doesn't, so basically what it does is that each word, right, is given a weight of how significant it is to that latent topic. So the words that you see occur at the front, right, are given higher weights. Yeah, so you can have words that have very small probabilistic scores, right? But they're still in the same topic. It's just depending on how they are clustered together. So these words can be maybe these words are bordering at the edge of the clusters, for example. But that is not something that we want to see, especially if we have hundreds of keywords. So in this case, what we do is we just see the most relevant keywords, the top 10 most relevant keywords in each cluster, for example. Yeah, and yeah, didn't run. So anyway, yeah, so I think this concludes the workshop. Sorry, yes?
Sorry, I wanted to know what's the actual application
Of topic modeling?
of this, like, what you have shared so far.
Okay.
What is being used in finance industry that has been found to be most useful?
Okay.
Do you all develop it in-house or do you all use cloud?
Cloud is simply a way you deploy the application. So when we look at how useful these things are, sentiment analysis is actually a known technique when trying to predict your price movements of commodities, of your futures, of your derivatives, or your asset classes in general. It is a known technique, for example. Topic modeling has proven to be a useful technique to help classify the topics that are related to your asset classes. So this is when we are looking more at a trading perspective. Entity recognition has been shown to be useful when it comes to client onboarding. Instead of getting a HR to manually look at this, okay, this is the person and put it here and stuff, right? It has shown to be useful when automating the entire process. Instead of letting a HR determine, this is the human, this is the subject, automate that process for client onboarding and stuff. In other forms, entity recognition can also be useful when trying to get sentiments about that particular person. That is when we start mixing things up. We get name entities, we determine the relationships between the subject and the object, and then we do a sentiment analysis to determine whether this action taken by this subject and object is a positive one or a negative one, for example. And then based on this, right, let's say, what's the guy name? Elon Musk? Tesla, yeah. Let's say we are taking, we use a name entity recognizer to derive Elon Musk. we find out what he's doing. Elon Musk is the subject. What's the subject? What's the object? Weed. Elon Musk smoke weed. Is this, according to the article that is being published, a positive or negative thing? Elon Musk smoke weed. Negative. Then you know, oh, maybe I should start shorting my Tesla stocks. So this is how you use all these NLP techniques to actually start to make sense of all the noise out there that in the market and try to automate certain processes. At the end of the day, machine learning, as mentioned, right, is an automated version of predictive analytics. It is used to help us predict to a better accuracy or to help us automate these kind of processes.
Do you also use this in conjunction with your algo trading and all?
My personal ones, right, I have found sentiment analysis to be quite clumsy because of all the noise and because of all the other factors. It's useful, and I have actually proven it in some papers and stuff, right? It's useful as an additional indicator, but it never should be used in silo.
Yeah, but for example, I have a decision on algo trading based on different, whatever the algorithms and volume thresholds I've defined.
Correct.
But if I also put, let's say, a weightage of whatever on the sentiment analysis,
yes,
would it also then help you make better decisions?
That is actually a good use case for machine learning. Instead of specifying your own weights, right, have your training and test data, let the machine determine what is the most appropriate weight to give sentiments such that your model is a better predictor of your price signals.
Right.
So that is actually a very good use case for using both machine learning and your sentiment analysis in the same time.
If you are just going by the sentiment analysis results, right, may not be.
No, you will just use it alone.
Yeah.
But the point is, how much will it affect your decision making?
Usually the sentiments are priced in the stocks or any assets.
Okay.
So pure technical analysis actually gets that. But you are going one level even deeper, that those stock prices movement, can I use sentiments and then those
Yes.
move properly?
So basically,
That
yeah.
still not there.
If you have predicted the stock price,
It's not me. It's I predict based on my algo, but then I know there is market sentiments, there is news, and there is geopolitical, or there may be weather, climate related stuff which can affect my commodities. And I use that information and then assign a weight and then trade more optimally probably.
it will help to tune your or maybe make your numbers more accurate.
Either I'll be bankrupt or I'll be willing.
Okay, so actually, according to research, right, specifically for pricing gold futures, right, the usage of sentiment analysis as an indicator, in addition to all the other various indicators like index pricing and stuff, right, has shown to improve the prediction by 2%. So in conjunction with other indicators accounted for weight, it is a better indicator overall. But used in silo, absolutely trash. Don't use it. Yeah.
Some of the top fund managers, they do use sentiment analysis just to tune their numbers.
Tune their numbers, right? Yeah. So it is pretty effective in that case, but I think it still has a lot more room to grow. For example, in the classic case of sarcasm, so one hot topic research area now is how do we detect sarcasm? The area that we're doing is context-based sentiment. So we need to know the context in order to know whether a person is sarcastic or right. Because sometimes even as humans, we don't know whether we are sarcastic. It's like I would say, hey Rajan, how are you doing? How's the workshop? It's great, man. Then like, is it really great? Yeah, so like you don't know whether this is, so getting a machine to predict that is even worse. So that's actually a top area of research, and there's a lot of news that use sarcasm out there. I think actually that's why Bloomberg doesn't use much sarcasm, so it's easier for us to get the. Okay, never mind. But yes, so there is a area that there's still a lot of room to improve for sentiment analysis.
But then the volume of data that the sentiment analysis can consume is much more than an individual do by himself. For example, if I'm a fund manager or an investor, if I go to, let's say if I want to invest in Samsung, okay, before I invest in Samsung stocks, maybe I will go to 100 websites, maximum 100 websites, and then I'll read about it.
Correct.
Whereas if I if I use sentiment analysis, it can go to thousands of websites and then download the data.
Gives you a score.
Yeah, it will
Yes.
give me a score. Rather, if I do it as an individual manually,
Yes.
I can only do it for 100 websites maximum, and then word of mouth inputs from my friend. That's it. Whereas if I use sentiment analysis, I can consume data from thousands of websites and then come to a prediction. Okay, whether investing in Samsung now is a good or a bad idea.
Correct. And in fact, you can use topic modeling to further enhance the accuracy of the sentiment, because not all websites are equal. Some websites are more relevant to your whatever funds you're holding, if you're holding in health or whatever.
One very good case which friend was asking that how do we use incentive this in finance industry. Recently Netflix has toppled down like 15+% because of revenue. Now is a good time to use sentiment analysis to go find out what is the market thinking about this, because there may be many of them who will think that, oh, this is overreaction, exaggeration, and probably you can make sense of that and actually buy that stock. Right?
Yeah, that's actually a really good case, because you can not only just scrape from articles and websites, you can also scrape from forums, you can scrape from Reddit, for example, Twitter, Facebook, all your social media, which gives you a perception of the masses. Yeah. Okay, so if nothing else, I'd just like to thank Data Science SG for hosting this.
Yes.
If you would like to attend more of these events in future, go to their Facebook and their meetup page and join them. They host a lot of these free events. And can we all stay back to take a photo? You should have said that before we all left. But yeah, okay, can we all take a photo so that we can just commemorate this special occasion? So anyway, if you are asking, right, these are the weights. So for example, penalties is 0.06.